Hello students, in this video I will go through exercise U4A04B where I will go through and apply concepts related to rectangles, squares, and rhombuses. Alright, so for the first question here it says, given each set of vertices, determine whether JKLM is a rhombus, rectangle, or a square. List all that apply and explain. So the first problem here, I purposefully, actually for the first four here, I purposefully did not include a coordinate grid in here because I want you to get into the habit of developing this muscle that's in every one of us, and that is to work with just the algebra. And how are we going to do this when this thing is so visual, right? So there's a rule, and that is whenever you are asked to work with any geometric figure, the order of the letters will always go either in a clockwise or counterclockwise orientation. Okay, so we can draw JKLM in this manner here. And it really doesn't matter. Okay, either way you draw it, the interpretation will always end up being the same. And that is, what is the interpretation I'm trying to go for? The diagonals. Okay, JL and KM will always be the diagonal. So again, the takeaway, whenever you're drawing any kind of geometric figure, the coordinates are always going to be listed in a clockwise or counterclockwise orientation, and it doesn't matter how you draw it. Notice that I did not place JKLM on a coordinate grid because there's really no need to. Okay, so with that understanding, okay, now we have a clearer sense of what which points form the diagonals, which points form the sides. So I'm going to work with the diagonals because that is, in my opinion, the quickest way of determining whether or not it is either a rectangle, square, or rhombus, just because the diagonals very, very quickly can tell us whether or not they are perpendicular bisectors of one another, and if they are, then that would mean that they are either a square or a rhombus. And to make it even more specific, then we need to determine the length of the diagonals. Okay, but anyway, let's get to it. So I want to work with diagonals here. I know that JL, let's try to find the length of the diagonal, because then we can then tell whether or not this is a rectangle or not if they have the same diagonals. So JL will be 4 minus 4, negative 4, plus 3 minus negative 1. And if I perform this computation here, that's really 8 squared plus 4 squared. And that's 64 plus 16, so that would be 80, square root of 80. I'm not going to reduce this because we really don't have to. And then KM will be our other diagonal. We're going to do negative 1 minus 1 squared, 3 minus negative 1 squared. And if we perform the computation, this is really 2 squared plus 4 squared. So they're clearly not, the diagonals are clearly not the same. So, so this is going to be 4 plus 16, so square root of 20. So definitely not a rectangle, okay? Now let's see whether or not they are perpendicular to one another. So it's definitely not a rectangle and a square. Let's see if it's a rhombus. To do that, I'm going to find out whether or not they are perpendicular bisectors of one another. So I'm going to find the slope of JL. So the slope of JL is 3 minus negative 1, 4 minus negative 4. And that would be 4 over 8. And that would be 1/2. So if this is a rhombus, the slope of KM would have to be negative 2 then. Let's see if that's actually the case. So 3 minus negative 1, all over negative 1 minus 1. And that would be 4 over negative 2. And that is indeed negative 2. That is the negative reciprocal. So we can conclude that JKLM is a rhombus, because diagonals are perpendicular bisectors of one another. Okay, so moving on to the next one. Again, in the same fashion, I really wish that they changed up the letters here, but for all four of these problems, they use the same lettering, but it's okay. So again, I'm going to find out what the diagonals are. I'm going to work with the diagonals. So JL is equal to the square root of 5 minus negative 3 plus 2 minus negative 2. And if I perform the computation, this becomes 8 squared plus 4 squared. And that is 64 plus 16. So again, that's square root of 80. It's very similar, but clearly they're different. They're different coordinates from the last problem there. Km is equal to square root of 0 minus 2 plus 2 minus negative 2. And let's see if this actually works out. So negative 2 squared is 4. So this is 4 plus 4 squared. So that's again square root of 20. Okay, now let's determine whether or not. So this is clearly not a rectangle. Okay, and it's clearly not a square, because if it's either a rectangle or square, the diagonals should be the same. So now let's find out whether or not they are perpendicular to one another. So the slope of JL is going to be 2 minus negative 2 over 5 minus negative 3. And that would be 4 over 8. And that is again equal to 1/2. And the slope of Km is equal to 2 minus negative 2 all over 0 minus 2. So this is again 4 over negative 2. So this is negative 2. So again, JKLM here is a rhombus. Because diagonals are perpendicular bisectors of each other. Okay, I have to say the problems are not that exciting, but for the sake of practicing, right? So JL is equal to square root of 1 minus negative 2 squared plus 5 minus negative 1 squared. And that would equal to the square root of, let's see here, that would be 3 squared, so that's 9. And then 6 squared, that would be 36, so this is square root of 45. And then I need to find out what Km is. That would be square root of 3 minus negative 4. 1 minus 3. So that would be 7 squared, so that's 49. Plus 2 squared, so that's 4. So the square root of 41, so square root of 53. So again, it's not going to be a rhombus, it's not going to be a rectangle or a square. Let's see if it is a rhombus. So slope of Km, or JL, is equal to 5 minus negative 1 over 1 minus negative 2 is 3 over 3, which is equal to 1. Slope of Km is equal to 1 minus 3 over 3 minus negative 4. And that is negative 2 over 7. So this is neither. So it's just, well, actually, we don't know whether or not the this is a parallelogram. So let's actually test for that. So right now we can safely conclude that this is not a rhombus, square, or rectangle because the diagonals are not congruent. That makes it not a rectangle or a square. And also it's not a rhombus because the diagonals are not perpendicular to one another. Oh, I forgot one really important thing. I forgot to test whether or not the midpoint's here for question 1. I'm sorry. So the midpoint is also important because the whole point of talking about whether or not it's a rhombus, we have to, describe whether or not it's a bisector or not. So I have to find the midpoint of JL and KM, okay? Of JL and midpoint of KM. I forgot that. Shame on me. Okay. So JL, the midpoint of JL is going to be negative 4 plus 4 over 0 over 2, negative 1 plus 3. So that's 0, comma 1. That's a midpoint. Let's see if that's the same for question 19 here. KM is negative 1 plus negative 1 plus negative 1 and negative 1 plus 3. So yes, this is a perpendicular bisector, so it does work. Okay, and I got to do this again. Midpoint of KM of JL, midpoint of KM. So for JL, it would be 5 plus negative 3. And 2 plus negative 2. So this would be 1 comma 0. And then for KM, it would be 2 plus 0. Negative 2 plus 2 over 2. And that would be 1 comma 0. So yes, this is a perpendicular bisector. I forgot to do the bisector portion of the math. And here in this case, okay, they're not perpendicular, okay, but we still got to determine whether or not the diagonals bisect one another, because if the diagonals bisected one another, then this is in fact a parallelogram. So let's do that, okay? So JL, the midpoint of JL, what is that? So that is 5. So that's 1 plus negative 2, comma 5 plus negative 1 over 2. And what is this? This is really negative half, comma positive 2. And we're going to repeat this again for KM, the midpoint of KM. So KM, 3 plus negative 4 over 2, comma 1 plus 3 over 2. And this would be negative 1/2, comma 2. So this is actually only a parallelogram. So JKLM is a parallelogram. Because only diagonals bisect each other. Okay. And let's go for the last one here. I wish they'd make it a little more interesting. So JL, okay, let's find the distance of JL again. So 4 square root of 4 minus negative 1 squared plus 6 minus 1 squared. This will give me a, if I do the math, that's really 25 plus 25, or it's going to be square root of 50. Do the same thing for Km. Km, that would be negative 1 minus 4. 6 minus 1. And then that would be 25 plus 25. Looks like this could potentially be either a rectangle or a square. Actually, no, it is a rectangle. So it's definitely a rectangle. Okay. Let's see whether or not it's a square or not. And to do that, we got to find out whether or not it's a perpendicular bisector, right? So JL, the slope of JL, is equal to 6 minus 1 over 4 minus negative 1. So that would be 5 over 5, which is 1. The slope of Km is equal to 6 minus 1 is 5. And negative 1 minus 4 is negative 5. So that's negative 1. So, and then we got to do the midpoint of JL. So the midpoint of JL would be 4 plus negative 1 over 2, and 6 plus 1 over 2. And that would be 3 over 2, comma 7 over 2. Midpoint of Km, that would be 4 plus negative 1 over 2, and 1 plus 6 over 2. And again, that comes out to be 3 over 2 and 7 over 2. So this is in fact a square then, because the diagonals are the same and the diagonals are perpendicular bisectors of one another. So JKLM is a square because diagonals, are congruent and are perpendicular bisectors of each other. Okay. Whew. All right. Question number 15. If WXYZ is a rhombus with W equal to negative 1 comma 3 and Y is equal to that coordinate, what must be an equation of XZ in order for WXYZ to be a rhombus? So what must be an equation of XZ? So in other words, okay, so I have WXYZ, again, you draw this picture. It's a rhombus, right? So WXYZ, they give you the coordinates of WY. That means you can find the equation of that line. They're asking not for the equation of WY, but they're asking for the equation of XZ. How can you do that? Well, to do that, we're going to find out what the slope is for WY. And the slope of WY is equal to 11 minus 3 over 9 minus negative 1. And that is 8 tenths or 4/5. So the slope of zx, or xz, will be the negative reciprocal of that, because this is a rhombus after all, right? So this is negative 5/4. Then we got to find out what the midpoint is of wy, because the midpoint of wy will be also the midpoint of xz. So the midpoint of wy will be 9 plus negative 1 over 2, comma, 11 plus 3 over 2. And the midpoint turns out to be, I'm going to write it over here. The midpoint happens to be 4, comma 7. So that's our midpoint. Okay? So the equation, because they're asking for the equation of xz, right? That's the equation of a line. So I want to write it in point slope form. That would be y minus 7 is equal to negative 5/4 times x minus 4. And if you want to write it in slope intercept form, you can certainly do that, but not necessary. But I'll do it anyway, because I know there are going to be many of you out there who will want to rewrite this in slope intercept form. But again, I encourage you to, get comfortable working with that form, point slope form, because it is super useful. Negative 5/4 x, distribute the negative 5/4 in, we get positive 5. Add 7, we get plus 12. All right? Okay. Higher order thinking. I like these questions. The longer diagonal of a rhombus is 3 times the length of the shorter diagonal. If the shorter diagonal is x, so the shorter diagonal is x. So if that's the case, that means I have x over 2 and x over 2. And this entire length, therefore, will be 3x. Right? If the shorter diagonal is x, what expression gives the perimeter of the rhombus? Ooh, okay. So that means this guy over here is 3x over 2. And this guy over here is 3x over 2. So in other words, we're going to apply the Pythagorean theorem here. So if I'm dealing with a triangle where I have x over 2, and this is 3x over 2, and I got to find out what that is, right? So it's x over 2 squared plus 3x over 2 squared. And this is x squared over 4 plus 9x squared over 4. And this comes out to 10x squared over 4. And that question mark there, right, is therefore equal to the square root of 10x squared over 4. I'm going to multiply that by 4 because I'm finding the perimeter. The perimeter will therefore be equal to 4 times square root of 10x squared over 4. Now, this thing can certainly be reduced, and I'm going to do that right now. X squared is a perfect square, so it's 4. So this becomes 4x radical 10 over 2. And since 4 and 2 can go into 4, this becomes 2x radical 10. That's the perimeter. Okay. For exercise 17 and 18, determine whether each figure is a rhombus. Okay, so here the leftover is 40, not because it has to be the same as this, but 100 plus 40 plus x has to equal to 180. So if that's 40, then that means this is going to be an isosceles triangle over here. And what else? This is parallel. We cannot say that this is a rhombus or anything for that matter, because what can happen is this can be drawn in this manner, and there's no way for us to tell whether or not that's the case. This could be 40 degrees, 40, 40, and 100, right? Where, again, these two lines are still parallel, and these are congruent. But wait a minute. This is congruent. So I take that back. Okay. So I take that back. I take that all back. So this is actually a parallelogram inherently, because I have one pair of sides that are parallel and congruent, but I did not notice this before. So this is a parallelogram with one pair of sides opposite, with one pair of opposite sides parallel and congruent. Therefore, this side here must be 100 degrees, and therefore this must be 40. So therefore, this diagonal here bisects the angle. This is indeed a rhombus. All right. Is this guy a rhombus? This is a parallelogram. However, notice that the diagonal is not drawn here. That's purposely meant to confuse you. So this is only a parallelogram. Because if this diagonal was drawn to the corner, I mean, this line here is not a diagonal. If that line was drawn to the corner, then yes, I would agree that would be a rhombus, but it's not. It's only a parallelogram. All right, next, we need to determine what kind of shape. The instructions are over here. What kind of shapes are these? Is it a rhombus? Is it a square? Is it a rectangle? Okay, so for this guy, I notice I have a pair of lines that are parallel and congruent. Therefore, this is a parallelogram. So this is definitely a parallelogram. First and foremost, that's a check. Because I have those angles there are congruent, then that means this is congruent because of alternate interior angle, and this is congruent because of alternate interior angle. And if that's the case, then that means these two sides are going to be the same, and these two sides are going to be the same because of angle side angle there. So this is going to be a square. Actually, no. Well, yes, it is going to be a square, because if these angles over here are consecutive, and they all, let's say we call them all x's, 4x must add up to 180, right? So therefore x must be 45. So that means this corner here must be 90. This is a square. Okay, next, this is a parallelogram. And why is it a parallelogram? Well, that's because this side is parallel to this side because of the reversal of alternate interior angles, right? I'm given alternate interior angles, so therefore those two sides are going to be parallel. And these two sides are going to be parallel because of, again, alternate interior angles. Okay, exercise 22 to 24. Give the condition required for each figure to be the specified shape. A rectangle. So in order for this to be a rectangle, for 3x minus 1 has to equal to x plus 13. Because all the diagonals have to be broken up into four congruent segments there. So therefore I get 2x is equal to 14, or x is equal to 7. So that's the condition. What is the condition for this to be a rhombus? So 6x plus 6 has to equal to 90 degrees because the diagonals are perpendicular bisectors of one another. So subtract both sides by 6, I end up with 6x is equal to 84. Divide by 6, I end up with 14. And then the last one here, what is the condition for this to be a rhombus? So 3x plus 12 has to equal to 5x minus 24 because the diagonals bisect angles. So therefore those two angles must be the same. So subtract 3x, I get 2x. Add 24, I get 36. Divide by 2, I get x is equal to 18. And that's it.